Alright, so this video is going to be on graphing angles in standard position, and we're going to graph both degree and radian measures in standard position. But the most important thing is that we're always going to start with a coordinate plane, right? The quadrant system, where we've got quadrant 1 goes counterclockwise, quadrant 2, quadrant 3, quadrant 4. And we're just going to keep going round and round and round. Okay, so I'm going to go ahead and label these. You're always going to want to do that. So we're going to start with the fact that this is 0 and 360. And then we go a quarter of a turn, which is 90 degrees. Another quarter turn gives us 180. Then we're at 270, and then that's how we get the 360 as well. And then in radians, we start at 0. A quarter turn is pi over 2. Full turn is pi, then, a full half turn, I guess. So not a full turn, a half turn. 3/4 a turn would be 3 pi over 2, and then back at square 1 would be 2 pi. Now that is just for a single rotation. You can continue to go round and round and round, and we will see that when we start graphing them. But when we are graphing something in standard position, we always start with the initial side, whether it is a negative or positive angle. The initial side is always on the positive x-axis. Okay, the initial side always starts on that positive x-axis. Okay, which is, from 0 to positive infinity on the x. Now, if we're positive, if our angle is positive, we are going to go counterclockwise, right? And that means this way. Okay, so we'll start with our initial side on the positive x-axis, and then we'll go counterclockwise however much of an angle it is. Okay, and we will use the guides, the 0, 90, 180, 270, if it's degrees, to kind of see how far we go around the units, or the coordinate plane. Okay, if it is a negative angle, and again, I've kind of done a bad job circling that, we're going to go clockwise. Okay, so our initial side, we still start on the positive x-axis, but now we're going to follow, how a clock goes. It's going to look like this. Okay, now that is why you must put in this, it doesn't have to be red, obviously, but this red arrow that's given, right? Say I didn't have that red arrow. Well, if this is my initial side, how am I to know if it's, a negative angle that's this big compared to a positive angle that's this small? Right, so you've got to have the arrow there, the line, to indicate which way your angle is going. Is it positive or negative? Okay, so here are some examples, right? The following angles are drawn in standard position, and these are all just degree angles. Okay, and this kind of right here goes to what I was talking about on the last slide, right? These two angles are actually the same. The thing that makes them different is we can see, okay, this is a positive 40 because it goes counterclockwise. This is going to be a negative 320 because it goes clockwise. Okay, and then, here's 160 just as an example, right? Keep in mind, we always start all of these. The starting side, the initial side, is on the positive x-axis, and then I guess I didn't mention this very carefully, but the kind of closing side of your angle is called the terminal side. So here are our terminal sides of the angles. Okay, it's important that we know that vocabulary because we're going to see it come up and use it to kind of help us with our graphing. Okay, this won't come up a ton in trig, but we will see it in pre-calc. 1 and 3 would be considered co-terminal angles because, again, they're on the same line. They look the same without direction, and that's going to be something that helps in learning target 3. Okay, so let's do an example in our examples, we're not going to draw this every single time. We're not going to map out every little piece, every little chunk. But what this will do when we memorize this, if we have an understanding of this, which in Learning Target 3, our main focus will be memorizing this, it'll help us do a best guesstimate, right? Like if I told you that I wanted to graph, 230 degrees. Well, for starters, I know it's going to be between 180 and 270, right? I know it's going to be in quadrant 3 because quadrant 3 is from 180 to 270. But having an idea and knowing, being familiar with the fact that 225 is halfway is going to help me when I'm sketching it because I'm just going to make it go a little farther than halfway, right? So my initial side will be along the positive x-axis, and then because it is a positive angle, I'm going to be going counterclockwise so I can kind of follow the measurements that are given. So going counterclockwise, I'm going to go all the way to 225 and then just a little bit past, right? These aren't going to be perfect ever because they're just estimates, but the terminal side should definitely fall in the right quadrant and in, about the right area. Okay, so there we go. Now I have graphed 230 degrees in standard position. Let's try a negative one. All right, so let's try and graph negative 130 degrees. And we kind of have two options here. The first thing you can do, which I don't often do, is we can use the fact that, angles that end on the same line are coterminal. And if we just add 360 here, that would give us the positive angle that lands in the same place. But then we have to remember to do the sides the same way. So the first thing I'm actually going to do is I'm going to relabel my sides. And I'm going to, it still starts at 0. But remember, with negative angles, we go clockwise. So this isn't 270 anymore. This is negative 90 degrees. This isn't 180. This is negative 180 degrees, right? A quarter turn this way is negative 90 degrees. Another quarter turn would give us negative 180. Okay, and then at the top, notice pattern is sticking. This would be negative 270, and this is negative 360. And not only can we do this with the quarter turns, but we can also say, okay, halfway between 0 and negative 90, that's going to be negative 45. Right, so you should start to notice that, I'm just flipping all the numbers in the different direction to negative because it goes clockwise. So now let me label a little more that are close to 130 because that will help me with graphing 130. So, rather than 240, this is going to be negative 120, right? It's 30 past 90, but 30 past negative 90. Then I really don't need any more. We'll call this negative 150. Okay, and again, the reason I'm labeling carefully in the third quadrant is because now I can see that negative 130 degrees, it's going to be in quadrant 3. Right? I know it's going to be in quadrant 3 because it's between negative 90 and negative 180. So again, as we have been doing, my initial side is always going to start on the positive x-axis. Then I'm going to go this time almost to 135. I'm going to get really close. I'm going to go almost, that's probably too close, almost to negative 135. And then I will draw my terminal side in, and now I have graphed it. And actually, now that I'm thinking, now that I've done this, it looks like I accidentally, graphed the same thing we did before, right? When we graphed 230 degrees, we started here and ended just a little bit 5 degrees past 225. So these are actually, notice again, these are the same angle. They are coterminal, but one of them we can see is positive 230 by the fact that I included this arrow. And the other one we can see is negative 130 by the fact that I included this arrow. So again, we've got to put the line here, the arrow, in the angle to show which direction it goes. All right, let's try one with radians now. All right, so let's say we wanted to graph, 7 pi over 4, right? We're going to start with our initial side here. It is a positive angle, right? So we're going counterclockwise, and we're going to go just to this is kind of on what you will soon find is called the unit circle. It's one of our known values. So I can just put it on this line and call it a day. Okay. This would also be the same, but a little different as if I wanted to graph negative pi over 4, right? Negative pi over 4, the difference would be is that I start here, I still start here, but then I go negative pi over 4 rather than 7 pi over 4. Okay, but things get tricky when, say, I wanted to graph something like, 18 pi over 15. Right? That's a little more difficult to see where it falls, right? In degrees, numbers are numbers. We can compare them easily. But fractions are a little more difficult to compare, right? It's easier to compare fractions when you have everything in the same denominator, right? I don't know if 18 pi over 15 is greater than 5 pi over 4 or less than 5 pi over 4. So how am I supposed to figure out how it goes? So for this type of problem, when we're doing radians and it's, over an angle we maybe aren't used to, what we'll do is we'll kind of put everything in terms of it, right? This is normally 2 pi. This is normally pi. Well, I can rewrite this as being 15 pi over 15, right? 15 pi over 15 is the same thing as pi, right? And this, 30 pi over 15 would go here. Okay, so now I can tell, it's going to be, 3 pi over 15 past pi. That's where 18 pi over 15 is going to land, right? 18 pi over 15 equals 15 pi over 15, which is right here, plus an additional 3 pi over 15. Now, 3 pi over 15, that can reduce to pi over 5, but we also, let's just compare it. Let's see if we can get a common denominator. And, we don't need to worry about getting an LCD here because we're not trying to solve anything out. So what I can do is, if I do, 15 times 6, whatever, I can write 7 pi over 6 over 90, multiply 7 times 15. So this is 105 pi over 90 would be 7 pi over 6. 3 pi over 15, I would multiply by 6 over 6, and it would become, I guess I should multiply 18. 18 times 6 would be 108. So this is the same thing as 108 pi over 90. And now we can compare the two, right? Now that we know, and I'm just going to try and write it over it, we know that this is 105 pi over 90. Well, if we're trying to plot 109 or 108 pi over 90, we know that it's just a little bit past that pink line now. So we kind of have an idea of where it is. So we start here. Then we're going to go just a hair past. Okay, and again, this is an estimate. But having everything in the same denominator is really what, seals it in for us that we can plot this particular, or effectively. Okay, so let's do some more example without the guidelines, because let's be honest, the expectation is not that you draw this wheel every single time you have to graph something in standard form, right? The expectation is that you have a coordinate plane. Okay, so when it's with degrees, we're going to start off by labeling the sides. So 0, 90, 180, 270, 360. So that's our first step. And then what we can see, okay, this is definitely going to be in quadrant 2, right? This is in quadrant 2. And we know it's in quadrant 2, and let me remind you, it goes 1, 2, that's supposed to be a 3, and 4. 1, 2, 3, 4. Okay, we know it's going to be in quadrant 2 because it's between 90 and 180. But then we have to make kind of an educated guess as to where it goes, or placement of it. So notice 177 is just shy of 180. I'm talking like 3 degrees. Now, that might be even too small for the eye to draw, but I'm going to really draw it pretty flipping close to 180. Okay, so my initial side is always the positive x-axis. And then I am going counterclockwise because it's a positive angle. I show the direction theta is going, or my angle's going, and then I'm good, right? And there are so many, options for success here and for earning credit in terms of placement. Well, maybe not so many, Obviously, it has to be in the right quadrant, but, if you had drawn something like this, sure, credit. If you had drawn something like this, sure, credit. Right? The idea is that the general placement is good, right? Something like this would definitely not fly, right? How is 177 so much closer to 180? And I know it can seem tedious to maybe label and stuff and show where it goes, but that can go a long way to getting partial credit in case you make an accidental, silly mistake. Okay, so now if I look at this one, negative 435 degrees, well, it's an angle in degrees, so let's again start by labeling. The difference is, though, it is negative, so we're going to have to go clockwise with our labeling, right? So we're going to go 0, negative 90, negative 180, negative 270, and negative 360. But then the problem becomes that we can't say, like we did last time, oh, this is in quadrant blank, because we don't have any quadrants that sandwich 435 degrees negative. So we have to keep going. So let's go another quarter turn, right? If we've gone fully around negative 90, negative 180, negative 270, well, now let's go another quarter turn, and that's going to be negative 450. And, we don't need to, but if we went another quarter turn, this would be negative 540. So now we know that this is in quadrant 4, right? And we know it's going to be about 15 degrees away from this. So let's start on the positive x-axis, as we always do. And then we're going to go clockwise. Okay, we go negative 90, negative 180, negative 270, negative 360, and then we go almost to negative 450, right? About 15 degrees away, which honestly, that's probably more like, 20 or 30, but again, it's a best guesstimate, an educated guesstimate, right? And again, on a test or a quiz, you're going to want to label the sides. You can't just throw an angle down there with no justification. Right, so degrees tend to usually be easier for people, but I'm telling you, radians can make just as much sense so long as you make everything comparable. So let's practice some radians. Okay, so just like we did with degrees, in standard position, you're going to, label the axes when you're going to graph. But the important thing is that you make the denominators match. Okay, that's the only way you can make an educated comparison is if you actually know, where the number falls between. Okay? So let's start with negative 25 pi over 18. You may have briefly seen this in class, but I didn't really go over it with most classes. So let's talk about it here. Okay, so I'm going to start by labeling the axes, and there's 2 things I have to do now. I have to label them with radians because this is clearly in radians. There's no degree symbol there, and that's got a pi. I need to do it in radians, and I need to do it clockwise, right? Because this is another negative angle. So we're going to go 0, negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. Okay, but now how am I supposed to decide which quadrant this is in, right? My idea would be, sandwich which quadrant it's in and figure it out. But with everything in different denominators, it's really hard to compare, negative pi and negative 25 pi over 18, or negative 3 pi over 2 and negative 25 pi over 18. So what we're going to do is we want to rewrite negative 2 pi over 18. So we want negative 2 pi to be written over 18. And that would be, you could actually solve this, but you really don't need to. You just think, what divided by 18 is negative 2? And that's going to be 36. So we're going to get rid of this, and we're going to relabel this axis as negative 36 pi over 18. We can do the same thing with pi, right? We want to write negative pi as being over 18. It's going to be negative 18 pi over 18, right? Yes, it would cancel. Yes, you could reduce that down to pi, but the whole point is we don't want it canceled, because without it canceled, it allows us for a point of comparison. Okay, negative pi over 2 is going to be 9 pi over 18, right? Don't need that. We're going to put negative 9 pi over 18. Okay, 3 pi over 2 is going to be 27 pi over 18, and there's two ways you can find this. Once we know that, going once around, or a quarter of the way around, is, pi over 2 in distance. So in this case, every quarter turn, we're going negative 9 pi over 18. Well, rather than doing this equation every time, we can just simply subtract negative 9 pi over 18, which you might think is more difficult. But given the fact that they have the same denominators, this is really just like saying negative 18 minus 9. And you kind of can't see my minus anymore. Negative 18 minus 9, oh, that's negative 27. But we have to keep the pi and the denominators. Okay, so now, and I'm going to get rid of this stuff while I talk. Now it should be clear for you to see, oh, this angle here, it's between negative 18 pi over 18 and negative 27 pi over 18, right? Negative 18 and negative 27 house negative 25 between them. So we know that this is going to be in quadrant 2. Okay, so now we've kind of seen, okay, it's going to be there, and we have to determine, between negative 18 and negative 27. Well, clearly it's going to be a little bit, kind of a lot bit, closer to negative 27, right? Negative 25 is much closer to negative 27 than it is to negative 18. So we're going to start with our terminal side on the positive x-axis. Then we are going to go clockwise because it's negative, and we're going to go, technically it'd be 7/9 of the way because we're, negative 18 minus 7, what I'm saying here, but we're just making an educated guess. It's going to end up right about here, and then that is when I draw my terminal side in. Okay, and this one is done. So again, all you have to do when you're graphing a radical to make it just as simple as graphing in degrees is give everything the same denominator. Because once it's the same denominator, you can make an easy comparison. All right, so let's do one more with radicals. 17 pi over 5. All right, so I'm going to start by labeling my sides. And for this method, I'm going to do kind of the quarter turn method. So I'm just going to figure out what pi over 2 is in terms of being over 5, which again, you can cross multiply and solve this, but you can also just do the denominator divided by 2. 5 divided by 2 is 2.5. So these fractions are equivalent. And I know that every quarter of a turn I make, and again, we're going counterclockwise this time because it's a positive angle. Every quarter of a turn I make, I'm adding 5 pi over 2. Okay, so, or why did I say that? I'm adding 2.5 5 pi over 5 every time I make a quarter turn. And again, it looks confusing because it's a fraction and it's got pi, but the pi over 5 part, that stays consistent every time. We're really just adding 2.5. Okay, that's how fractions work with common denominators, which is why we want to make it a common denominator. Because now, if I go another 2.5 pi over 5, really all I have to think is what's 2.5 plus 2.5. So it's going to be 5. So we have 5 pi over 5, which makes sense because that's pi. Then I add another 2.5 pi over 5. All I have to ask myself is what's 5 plus 2.5? 7.5. So 7.5 pi over 5. I go another 2.5 pi over 5. That's going to be 10 pi over 5, which again makes sense because it's 2 pi. That's not enough, right? Again, I don't have a quadrant that I can sandwich 17 in, right? 17 is not between any of these, so I have to keep going. Oops. I have to keep going around and around. So I'm going to add, and this time I'll change color. I'm going to add 2.5 again. This would give me 12.5 pi over 5. Add 2.5 again. That's going to give me 15 pi over 5. Add 2.5 again. That'll give me 17.5 pi over 5. Add 2.5 again, and we have 20 pi over 5. Okay, and then from there, now I do have something I can sandwich, right? Now I do have what I need. And I can see that 17 is between 15 and 17.5. Because I have made my denominators equal, then that's how I know that this is in quadrant 3. Because the denominators are equal, I just have to look at these numbers. Okay, and I can see that 17 is sandwiched between 15 and 17.5 pi over 5, right? And notice it's a lot closer to 17, right? It's 2 away from here. This is a difference of 2 pi over 5. This is only a difference of 0.5 pi over 5. So it's really important that we note that it's going to be a lot closer to 17.5 than it is to 15. So let's start by drawing our initial side, as we always do, our initial side on the positive x-axis. And then again, we're going to go all the way around once, right? 2.5, 5, 7.5, 10, 12.5, 15. And then now we make the decision, okay, 17.5 and 15.5. 17 is going to be, if we're, counting up, if we chunk this into, a 2.5, it's going to be like right about here-ish. So we'll go here. Again, we're making educated guesses here. It's obviously not halfway in between. Honestly, this is probably a pretty bad educated guess. It's probably more like this. But so long as it's clearly past the halfway line, right, clearly closer to the 17.5, then you've done everything you need to do. Okay? And so that is it. That is my notes on graphing something in standard position. I would definitely say it is the hardest part of this learning target, probably why this is a 30-minute video, but I hope it helps. If you have any follow-up questions to anything I covered here, please send me an email with them. But good luck on your homework.